Hello and welcome back to Mr. Adelman's fantastic math class. Continuing on in this section with proportional parts with parallel lines. Today we're going to talk about one of the more useful tools that we'll see. It's useful because it has many applications, but it does have a little confusing definition. So we're going to divide segments proportionally. It says, if three or more parallel lines intersect two transversals, then they cut off the transversals proportionally. Okay, great. What does that actually mean? Let's take a look. Okay, so it says if this line AD is parallel to this line BE and CF, and again they're cut by two transversals, then we can set up a few proportions that are true. We can say that AB, this segment right here, AB divided by BC, that's going to equal this segment DE over EF. So that's one of the proportions that is true. The next proportion is if we take the entire segment from A to C and we put that over this entire segment from D to F. Well, we're gonna use that proportion again in a second, but that's going to give us the proportion of this segment AB over, you might have guessed already, DE. And finally, again, we're going to use this proportion AC, so the entire length there over the entire length here, DF. And that's going to be equal to the proportion of BC over EF. Okay, so let's take a look at how we might use this. This problem always sort of reminds me of when I used to live in the Brighton section of Boston, where Brighton Ave and Com Ave intersect. It sort of reminds me of these two. It's crossed by a few roads, Harvard Ave being the major one. I used to live on Chestnut Ave, and Mass Ave is actually technically not here. It's much further down, but I just used it as an example. I just remember there was a great wing place right here. It's called Wing It. They had the best honey barbecue wings you've ever tasted. But we could figure out the distance using this, and there's a couple ways we could do it. We could say that. We could say that this section, if we put 13 over 26, that would equal 16 over x. That's one way we could figure that out. We could also say that the entire thing, so 13 plus 26 over 16 plus x, that could equal 26 over x. We also know the proportion of 13 plus 26, so 39 over 13. I'm sorry. 39 over 16 plus x would also equal, so 39 over 16 plus x would equal 13 over 16. Yeah. Now, all of these true, but obviously some are easier to deal with. So we're going to tackle the one that's the easiest to deal with, in my opinion. That is this one. It only has one variable, so we're going to use that one. So let's take a look. It's going to be, I'll slide you up a little here, 13 over 26 equals 16 over x. Now, I can cross multiply here. And so I would get 13x equals 26 times 16, but off the top of my head, I don't know what that is. But what I also can do is recognize that if I have 13 here and a 26 there, well, I know that 13 goes into 13 once and to 26 twice, so I'm just going to simplify that fraction. So instead of doing that, what I'm going to come up with is 1 times x, so x, and that's going to equal 2 times 16. So I simplified the fraction before I did this. So that's going to give me x equals 32, and I said it was 32 yards. So that's one way that you can use dividing segments into proportional parts. That's all we have for today. I hope you enjoyed yourself as much as I have. Have a great day. Take care of yourself.